section 3.2. 3.2 is all about long division. Okay, so we learned how to factor, or we were called factoring, just what times what equals this, and adds to give us that. We also looked at the decomposition. Is that what it is? That's when the value in front of the x squared is greater than 1, right? Or negative. Then you have to do this times this and this plus this, but then you have to break it and group, right? But we've never looked at factoring anything greater than x squared. Guess what? You're going to be asked to factor things that are greater than x squared. X cubed, x fourth, x to the fifth. That's what we're doing, polynomials. Okay, so we're going to go back to long division. Now, I know you guys have done long division before, or I think you have done long division before. So we're going to go back old school. Okay. 463 divided by 3. So we put the 3 on the outside here, right? And then we put 436 underneath the root sign, right? Underneath the divisional sign. Then, what do? How many times does 3 go into 4? 1 time. Carry it down. How many times does 3 go into 13? 4 times. That gives us 12 because 3 times 4 is 12. Carry the 1 down, bring the 6 down. 3 goes into 16. 5 times. 3 times 5 is 15. And we get a remainder of 1. Okay? Now, to verify this, what do you actually do? You go 145 times 3, but what do we do with the remainder at the end? We add 1 at the end. So 3 times 5 is 15, carry the 1, 3 times 4 is 12, 13, gives me 335. No, I missed the carry the 1 when I did that, so that gives us 435. When we add 1, it gives me 436. Works. We're going to just do remainders because when we carry it into polynomials, we're going to do remainders on polynomials. Okay. So, are you ready? On this side, I was just checking to make sure that I did my division right. So I can write this as x plus 1 divided by x squared plus 2x plus 5. When we do polynomial division, you have to make sure that it goes x squared x in a number, or x cubed x squared x in a number. You can't miss out anything. Thanks, Montana. If you miss out on something, you have to put a 0 there. So if it was just x squared plus 5, I'd write x squared plus 0x plus 5. Okay? So this is where we have some fun. So what can we multiply by x plus 1 to get x squared? We just worry about the first one. What can we multiply x by to get x squared? Another x, right? Because x times x is x squared. Oh, good. X times x is x squared, but we got to remember that we had that plus 1. So we got to, you kind of have to like distribute, right? You got to remember that it's this times this and this times that. Okay? So x times x is x squared, and then x times 1 is plus 1x. Then we subtract. X squared minus x squared, nothing. 2x minus what times x, because remember we're just looking at the first things. Now if we multiply by 0, we'd get nothing. We'd multiply by 1. Okay, so if we do that, x times 1 is just x. 1 times 1 is 1. If we do the subtract, x minus x gives me nothing. 5 minus 1 will give me 4. That's the end of the line, right? So I go back to the top and I say remainder 4. So then if I asked you to verify, what would we do? Good. Here we multiplied what we were dividing by what we found as our answer, and then added 1. So we'll go x plus 1, because that's what we divided by. Then what's on top? X plus 1. And then we would FOIL, and we would add the remainder of 4. So let's check to see if we get the original thing we were trying to divide. Okay? FOIL, x squared plus 1x plus 1x, so 2x plus 1 plus 4 gives me x squared plus 2x plus 5. Is that what was underneath the dividing sign? Okay, this is just to verify, right? What's our real answer here? This is our real answer. The x plus 1 remainder 4. Okay. When you multiplied x times x is x squared, 1x, 1x, and then 1 times 1 is 1. Yeah. Okay. So, let's carry on. And I told you we had to divide things that were greater than x squared, right? So, let's do it this way. How would I set it up? X plus 2. Then I do the big divide sign. Minus x minus 6. Beautiful. So, Jesse, what's our first one? What times x will give us 2x cubed? 2x squared. Good. So 2x squared times x gives us 2x cubed. What do I do next? I multiply the 2x squared plus 2 will give me plus 4x squared. And I end up with a negative x squared. And I bring down my minus x. Oh, I don't know, because I'm really bad at math and you guys are much better. Okay. You have that on recording. Okay. So, now what do we have to do? We have to try and get this one, right? We never, when we were doing our original division, we never looked back up here to see what it was. We looked at the number that was underneath, right? True. So now, when we're doing this one, same thing. We're looking at this value here, this x squared. What times x will give us x squared, Dylan? Positive x. So then we go into here, x times x is x squared. X times 2 is plus 2x. And we subtract. We get negative x minus 2x, negative 3x. And we bring down this minus 6. Now what should we do there, Jocelyn? How do we get an x to get a negative 3x? We times by a negative 3. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. What does that mean when it goes to 0? x plus 2 times 2x squared plus x minus 3 should give us, what should it give us? It should give us that thing, right? Straight out. So let's FOIL. Oh, you guys. No, how do we FOIL when there's 3 terms? Thank you. You still just do it 1 to each, right? X times each 3, and then you'll do the 2 times each 3, and it'll all be okay, right? 2x cubed plus x squared minus 3x, and then the 2 in here, so plus 4x squared plus 2x minus 6, right? Are all my terms okay? 2x cubed, x squared minus 3x, then the 2 times 2x squared is 4x squared, 2x minus 6. Now I combine, so I have what? 2x cubed, how many x squared? 5x squared. How many x's? Minus 1x, and then minus 6. Is that what was underneath there? Yep. So it checks, it verifies, we're good. Then there was this big monster thing at the very top. How can we write it in that form? What was the original polynomial? 2x cubed plus 5x squared minus x minus 6, and then it's divided by x minus a, so we're dividing by x plus 2. What does that equal? 2x squared plus x minus 3. Did I have a remainder? If I did, I would do the remainder divided by the x minus a. But this is this, right? This big statement is just this. The original polynomial divided by what we're dividing by is equal to whatever my answer was up here plus my remainder divided by this thing. But 0 divided by that thing is just 0, right? Do you want to try another one, or you think you're okay with this stuff? Okay, so what do I put out in front of my division sign? X minus 1. What do I put underneath here? Oh, they tricked me. X cubed plus 3x squared minus 2x. Good. Now, if there was no x squared, you'd have to write 0x squared. So, what times x will give me x cubed? X squared. Okay, how do I get these numbers under here then? X cubed minus x squared, and this is a subtraction, right? So what's my answer right here? Three minus a minus would be 3 plus x squared, which will give us 4x squared. Let me bring down a minus 2x. What times x will give us 4x squared? So plus 4x, and we distribute again. 4x times x is 4x squared. 4x times negative 1 is negative 4x. We subtract, we get minus 2x minus a minus, so plus 4x, so plus 2x, and we bring down the 5. What times x will give us 2x? Plus 2, and we get 2x minus 2. So we want to verify. So to verify, we've got to go x minus 1 times x squared plus 4x plus 2. But now that we have a remainder, we have to add 7 on the end. Okay? So gives me x cubed plus 4x squared plus 2x, and then I've got to go with the minus 1's. Minus x squared minus 4x minus 2, and then I'm just going to add this plus 7 at the very end. So then we combine our like terms. What do we get? Negative 2x plus 5. It should be a plus 3x. Oh, 4x squared minus x squared gives you a positive 3x squared. So a simple algebraic mistake made me think I did something wrong. So a quick check of my positive negatives. Adding, it works. How do we write it in that kind of fancy way then? You ready to see this fancy way? Like the thing at the top. You would write it as x cubed plus 3x squared minus 2x plus 5 all over divided by x minus 1 is equal to x squared plus 4x plus 2. But now we have to do something with the remainder. Plus 7 over, what do we put it over? Because this number is this divided by that already. The only thing that's left over is this 7, and we haven't divided it by x minus 1 yet, so that's why we leave it as 7 over x minus 1. I think you guys are okay. I don't think you need to see this last one. Okay? The big thing about this one, it was missing an x squared, right? So when you go to write it out, it would be x minus 2, and then the square root of 3x to the 4th plus 2x cubed plus 0x squared minus 6x plus 1. Okay? That's the key thing. If they don't give you an x squared or one of those values, you have to input it and hold its spot. Okay? If it started at x squared and it didn't have an x, you didn't have to put anything in for cube, so there's no 0x to the 5th. It's just wherever it starts at. Okay? You guys remember synthetic division? This is the faster way, and usually less mistakes are made this way. But you should be able to know both ways. Whatever way you like is the way you do, right? I'll never tell you you have to do one way or the other, but I'll show you all the different ways. So, are you ready? You guys remember this upside down L? This is 2 lines in your notebook. 1 line, 2 lines, and then a line for the answer. Okay? Now, up here, I am taking the coefficients of the values. Okay? Do you see where I got those numbers from? Now, how did I get that number? That's the A. We took it out of the brackets. Okay? So I'm going to carry the first one down and put it at the bottom. x number is your remainder. Okay? After that, you count, this is your constant, so remainder, this is your constant, this is your x squared. If there was another one, it would be your x cubed. Okay? So my answer is 2x squared plus 1x minus 3. That's equal to, what was my original question? 2x cubed plus 5x squared minus 1x minus 6, all divided by x plus 2. No, it doesn't matter which side it on. This would be the answer. I wouldn't even write that other stuff. But that's what that is. It's the division of those two things. I would just write that. Okay, good. So, how did we get this negative 2? We know how we got these numbers. They just come straight in, right? To get the value out here, you set what you're dividing by to 0, just like we normally do for anything that's like inside of brackets normally. So we get x is minus 2. Okay, and that's how I get that number for out there. Okay? Yes, it has to be in order, and you can't miss out anything. So if there's a missing x squared, we put a 0 still. Okay? So let's take a look at another one. So Nicole, what am I putting up here? Oh, I thought she was here. She left when I was in the other room. Okay, that's fine. I just have to change my attendance. I didn't even notice. That's crazy. Cheyenne, help me out here. What goes up here? And then over here? Good. You just set x plus 3 equals 0, and that gives you x equals negative 3. That's how we get it there. How do we start? Do you remember, Demara? Drag the 2 down. Then what do we do? Negative 3 times 2 gives us negative 6. Now what do I do? Add negative 11. Now I positive 33. That gives me 29. Whew. And negative 85. What's this negative 85? That's my remainder. Okay, so I could write that here's my answer. 2x squared minus 11x plus 29 with a remainder of negative 85. Okay, we could also write it in that big long kind of way where it's what? 2x squared minus 11x plus 29 all plus negative 85 over x plus 3. And that's what the original question equals, right? I did this one, the one we just finished finding, times by this one out front. So negative 3 times negative 11 gives us a positive 33. Then we add, and then 29 times negative 3 to give us the negative 87. Okay? Synthetic division goes a lot smoother, right? Do you guys have one of these? Yeah?
So for that big form that we're supposed to put the result in, are we always supposed to do that? Or?
That's a textbook kind of thing that they like to do. So when you see the answer in the back of the book, you'll see it in somewhat of this form. So I want you to see what your answers might look like. When I used to do this in math, now I'm dating myself. Back in Math B30, this is what we did. The top one. If it says it has to put it in that form, I would say try, because some of the multiple choice you're going to see answers that look like that. So you want to know what works, how that works, right? Even when I do multiple choice, because I borrowed the textbook's multiple choice thing, so I'm not going to switch all the answers. I'll tell you I cheat sometimes too. It's okay. Do you guys want to do another one? Yeah, okay. One more. Okay. Is the next one? Is there another one? Okay, no. Oh, good. Let's do this one. Because it's ones with zeros. Okay. Here we go. How do we set this one up? That's the x to the fourth. That's x cubed. That's x squared. No, we need another 0. That's the x. And then the 1. Okay? So you have to hold spots for anything that's not there. So it started at x to the fourth, x cubed, x squared, x, and then the constant. Okay? If there's no constant, guess what? You have to put a 0 because the constant's 0. You even have to hold that constant spot back here. Okay? What number goes out in front here? A positive 1. So we carry this one down, we get 1. 1 times 1 is? 1. Oh, he's going too fast. 0 plus 1 is 1. 1 times 1 is 1. Add gives me 1. So what's this? The remainder. So when I go write my answer, this is constant, this is x squared, and this is x cubed, right? So I get 1x cubed plus 1x squared plus 1x plus 1 remainder 2. Oh, no, you could just write x cubed plus x squared plus x plus 1. That's probably even more proper. Remainder 2. Okay. Way easier. I don't care which way you remember it. The long division way, you've known the method of long division, so it's easy if you forget how synthetic works. Synthetic, you have to remember the process, whereas the long division, you guys have that ingrained in your brain. Okay? So if it comes to an exam time and you're like, I can't remember this synthetic thing, you can go back. No. Remainder theorem. Now, eventually, you guys, we're going to want to factor these big things, right? So we want them to divide evenly. But do you want to do synthetic division after synthetic division until you figure out you have a remainder of 0? Because if it's a remainder of 0, that means it's a factor. Okay? There's an easier way to figure out if the remainder is 0. Okay? So this is the thing we were dividing, and we divided by that. That gave us a remainder of 0. Okay? Do you remember that? That was one of the ones we did. If we take what we're dividing by, set it equal to 0, and solve for it, negative 2, we can put that in for every single value of x. Just shut it down. Every single value of x. So if I go 2 times negative 2 cubed plus 5 times negative 2 squared minus negative 2 minus 6. If I go into my calculator and punch that in, what do you think we're going to end up getting? Good. Your guys' calculators are probably faster than mine. Did you plug it in? So you're just assuming. Okay. What did we have? Negative 2 cubed. Oh, you guys found it already? Okay. A equals 0. When you plug that in, that equals 0. What was the remainder? did another one that we have done before. Let's go back. Which one did we do and it didn't have a remainder? Here, this one. If we did this one, what do you think the remainder will end up being? Negative 85. It should be, right? Not that I was expecting you to calculate it out. So what value would we put in? Negative 3. So if we go 2 times negative 3 cubed minus 5 times negative 2 squared minus 4 times negative 2 plus 2, because I ran out of room. You're right. I changed my mind halfway through. That's a Miss Para thing to do. Okay. When you substitute that all in, negative 3 cubed is negative 27 times 2, carry on, that's negative 54, and then we subtract this thing, we carry on. What do we end up when we punch it into our calculator? Jesse's doing that for us. Booyah! Even faster than synthetic division to figure out whether it's a factor or not. But then once it's a factor, you're going to have to do synthetic division or long division to figure out what it equals. Yeah, you could just check your remainder. Right. So, chances are that if it works, if it's 0, then it's a factor. If it's not, then it's not a factor. So eventually, I'm not going to just ask you to divide, I'm going to ask you to factor things, right? So you're going to want to remember this theorem. Are we done? Oh, we're not done. You could do this top one, because we did an extra one. Kind of. But this is another example, but this is a little different. It says, determine the value of k if the remainder is negative 2 when we factor this thing. You can't really do synthetic and go backwards because you don't know what that k value is, and that's the first thing you pull down. Right? Oh. So we could do like p of positive 2 is equal to k times 2 cubed minus 4 times 2 squared minus 5 times 2 plus 8. But what does p of 2 actually equal? The remainder, right? Because if it was a factor, it equals 0, but it's telling us it has a remainder of negative 2. So we could plug negative 2 in for p of 2. 2 cubed is what? 8. So I'll call this 8k. 2 squared is 4. 4 times negative 4 is negative 16. Negative 10 plus 8. How are we getting k? How are we solving for k? We have to get it by itself. Okay, so this is negative 26. If we add 8, that's negative 18. So we're going to add 18 to the other side. So we get 16 is equal to 8k. So then divide by 8, k is 2. So if they give us an unknown, we can use the factor theorem to figure out the leading coefficient, right? If they tell us what the remainder is, and if they said it's a factor, we would put 0 here instead of putting negative 2. Okay?
They said it's a what?
A factor. So for what value of m will the polynomial have the same remainder?